Today we are discussing about a Lex a program to recognize a valid arithmetic expression. For this we are using one of the Unix utility called Lex command, and this Lex command it is responsible for generating an lexical analyzer, and the job of the lexical analyzer is to translate the given stream of input strings into a stream of tokens. The input for the lexical analyzer is what it is, a string. It is converted into token by using the patterns specified in the form of a regular expression. Okay, so next we'll see the structure of a Lex program. This is the structure of a Lex program. It is containing three sections: a definition section, a rules section, and code section. Rules section, it is written between two percentage signs. It begins with the 2% signs and ends with the 2% signs. And in the definition section, we can declare some of the variables, and at the same time we can initialize the variables also, and we can include any of the header files required for the program. Okay, and in the code section it is same as our C code. Okay, in this code section mainly we are going to invoke an lex function inside the main function. This is the structure of a lex specification file, and these are the execution steps. Lex specification file always has got an extension .l. The first step, we need to use any of the editor. In this case I am using gedit editor in order to create a file. Okay, first command is a gedit followed by a file name, and the second step, okay, once the Lex specification file is created and written a program, then that Lex specification file, you see the second step, that is the Lex specification file prg1.l is passed as an argument to a Lex command. Here this Lex command, it is responsible for generating an lexical analyzer, and that lexical analyzer is represented by using an C code, that is lex.yy.c. Okay, once the Lex analyzer is generated by the Lex command in the second step, okay, and that lexical analyzer or the C code that is represented with the file lex.yy.c is passed as an argument to a compiler command, that is a cc command. That C code, it is given for the compilation by using a cc command with this option, that is -ll. -ll it is an option in order to link any of the library routines required during the execution of a programs. Those library routines are linked with the help of this option, that is -ll with cc command. Then the fourth step is what, that is once the code is given for the compilation, executable file is ready, that is a.out, and it is given for the execution with this command, that is ./a.out. okay, once the program is executed, then okay, we can say that the given expression in the program, whether it is a valid or invalid arithmetic expression. Okay, now we'll see the program. See, these are the execution step. The file Lex specification file is given to Lex command. Lex is responsible for generating lex.yy.c. This itself is the lexical analyzer. It is given for the compilation. Then it is given for the execution with this command dot forward slash a dot out. See, this is an Alex program in order to recognize whether the given expression is valid or not. Okay, and see here it is containing a three section, and the first section is what the rule section, and the second section, first section is the definition section, and the second section is rule section, and the third section is the code section. Okay, you see the first section, that is definition section, it is always enclosed in a percentage open and ends with a percentage closing flower brace. Okay, it includes the initialization of variables, and here we are including one of the header file, that is stdio.h, and along with that we are initializing some of the variables. Okay, next part is what, that is rules section. In the rules section, okay, it is containing two things. The first thing is what it is in that is the pattern, okay, represented in the form of a regular expression. Okay, and for each of the pattern we have got the corresponding action is always written in a flower brace, and the action code is same as our C code. Okay, see, for the first pattern is what, a 0 to 9 enclosed in a square bracket followed by a plus, that we call it as what, a character class. Character class is containing a number from 0 to 9 followed by what, a plus operator. Okay, this pattern, it is responsible for matching any number. Okay, if any of the number is present in the given input string, that is matched with the help of this pattern, the first pattern itself, and once the matching occurs with a particular pattern, the corresponding action is going to execute. Okay, the id means, id is what, in order to represent an identifier, id is incremented by 1 and the corresponding identifier is printed. Okay, and here you see this is an yy text variable, and it is used by the lags. Okay, this yy text variable, it always containing the currently matched pattern. Currently matched string with a particular pattern is stored in a variable, that is yy text. Okay, this is with respect to the first pattern, and next you see the second pattern, that is character class containing a plus and the asterisk. Okay, if the in the input string, if it sees an plus or an asterisk, if it treats and plus, the plus is first it tries to match with the first pattern, it fails in matching with the first pattern, and next is what, it takes the second pattern, the plus is exactly matching with the second pattern. Once it matches with the pattern, okay, the corresponding action is what, op stands for what, to keep track of number of operators present in the expression. OP is incremented, and we are followed by what, a printf function, that is which operator, that is the currently matched operator. Suppose if it is an plus, then that is present in an yy text. The content of yy text is displayed with the help of a printf function. See, this action is always enclosed in a flower brace. Okay, in the input expression, okay, if it is containing any open brace, it is matching with a open bracket, half bracket, that is the third pattern specified in the rule section, and the corresponding action is what, that is we have taken and one of the variable, that is v, to check whether it is the given expression is containing an balanced parenthesis or not. Once it sees an open bracket, the v is incremented. Once it reads an closed bracket, okay, v is decremented by 1, and finally after reading the entire expression, the v count should be 0. Okay, next is what, okay, dot. Okay, other than these characters or these operators, that is plus and asterisk, okay, if it sees any of the other characters, okay, in the expression, then the flag is set it to 1. That is the fifth pattern specified. Then it takes an, okay, it is reading a new line character, and there is no action with respect to this new line character. Okay, these are some of the patterns specified in the rules section in order to recognize an arithmetic expression containing what identifier should be, must be what, integers, and operators could be only plus and asterisk. That is the objective given in this. Okay, next thing, in the main section, that is in the main, we have got, and that is in the main function, that is the next part of it is what, it is a code section. In the code section, usually we invoke an yylex function. Okay, yylex function, it is responsible for generating an lexical analyzer. See, in the main section, what is the first statement? The first statement is, okay, just we are printing a statement, enter the expression, and next is we are invoking an yylex function. This yylex function, okay, it generates a lexical analyzer. Once this starts its execution, once the control is transferred to yylex function, it takes a stream of characters from the keyboard, or from the input file. Okay, once it reads a stream of characters, and those stream of characters or a sequence of characters present in the input file or from the keyboard, if those stream of characters, it tries to match with a particular pattern in the rules section. If it is matching with any of a particular pattern in the rules section, then the corresponding action is going to execute, and this is continued until the until it reads an until it reads the end of the character in the input file or from the keyboard. Okay, say for example, we have got an expression, that is we are printing a statement, that is printf of enter the expression. After that, we are going to invoke an yylex function. At this point, if I give an input, that is 3 plus 4. Okay, what is the 3 plus 4? Okay, then first it reads an 3. Okay, and that 3 is, okay, it tries to match with a pattern, that is the first pattern, second pattern, so on. Okay, see here 3 is matching with the first pattern, the corresponding action is going to execute. Any matching occurs, okay, corresponding action is going to execute, and the currently matched string is present in an YY text a variable. In this case, it is 3 is matching with the first pattern. Okay, corresponding action is what, ID is incremented at the same time, that is 3 is printed on the screen as an identifier. Next, it reads and next character, that is a plus. Okay, plus it tries to match with the first pattern, it fails in matching with the first pattern, and it next it tries to match with the second pattern, exactly it is matching with the second pattern. Okay, corresponding action is going to execute, that is operator count is incremented, and it that is matched pattern is what, that is matched string is present in the YY text, that is displayed with the help of printf function. And next is what, 3 is over, plus is read by the lexical analyzer, and the last one is what, 4 is matching with the first pattern, and the corresponding action is going to execute, that is ID is incremented, and the content of currently matched string, that is present in the YY text, a variable that is displayed with the help of printf function. Okay, in order to check whether the expression is valid or not, we are using the next part, that is if else part in the main section, that is if of operator plus 1, if it is equal to ID count. Okay, the operator, if I take the 3 plus 4 expression, OP plus 1. What are the number of operators? That is 1. It is OP content is what? 1. 1 plus 1 is what? 2. It is equal to ID. What is the content of ID? It is containing 2 identifiers. The count of identifiers in the given expression, that is 3 plus 4 is what? It is 2. So OP plus 1, it is exactly equal to ID, and V is equal to 0. Okay, whether we have gotten balanced parenthesis or not, for that we are using this variable, and it should be 0 always after reading the entire input expression. Next, and it is ANDed with, okay, the flag variable, any of the other characters, that is in the question itself is mentioned, okay, the arithmetic expression must consisting of only integers and operators, that is plus and asterisk. Okay, if any other than those, okay, if any of the other characters are present, okay, that is identified with the help of this flag variable. This flag should be always 0. If all the three conditions are true, then we are printing a statement, the expression is valid. Else, if any one of these condition fails, then we are printing a statement, the expression is invalid. This is the explanation of a first Lex program.